Hey Joey.
Hey Chiong, how you doing?
Hey, okay, good. Okay, so I think we can start
Yeah,
now.
no problem. So just hi everyone, I'm Joey, and that's Hong from GDGKL.
Yeah.
Welcome to the Google Developer Space channel and the GDGKL channel. Thank you for tuning into the live stream today. So yeah.
So thanks for coming to our TensorFlow Study Jam today and joining us on a Saturday afternoon. So today we're gonna just go through some more of the beginner and slightly more intermediate levels of Study Jam code labs.
Yeah.
Right. So if you aren't already, do remember to join our Facebook group if you are interested in more GDG Kuala Lumpur events. And if you want to join the discussions, or if you want some materials that the instructor will be sending, so you should join our Slack because we'll be sending everything there. And it's easier for the instructor to answer questions as well. Right, so maybe I'll just show this for a little bit more, and then we can move on. Okay, I think if you are trying to get it, then you can pause the stream for a little bit, and then we can continue. Right. So what is the Study Jam? So Study Jam are community-run study groups. So community-run, as in we're run by groups like GDG Kuala Lumpur and Singapore. All around the world we have Study Jams, and they give like a more specific skill. So you can, for example, we do like Study Jams for web, Study Jams for TensorFlow, and then other stuff as well. For example, Google Cloud. So, So I think we can introduce Lifeng. Lifeng.
Yeah, let's add Lifeng to the stage.
Yep.
Hi, Lifeng.
Hello.
Hi.
Hi,
everyone.
So we'll be starting with Collab 1, which is the Hello World of Machine Learning, and this will be the link. So maybe I can pass the stage to Lifeng.
Yeah, no problem. Before that, I think just to some questions coming in from the live chat already. Chi-Hong, I think they're asking for the link the link to the Slack channel so that they can ask questions. Yeah, so everyone, it'd be great if you can join the Slack channel. Chi-Hong will be sharing the link on the live chat really soon. Yep. So there it is. So if you could join and then direct all your questions there so that Lifeng can get to it during the code labs as well. Yeah, I guess without further ado, let's pass the stage to Lifeng to kickstart the session. And thank you everyone once again for joining Google Developer Space and GDGKL for the live stream today. Okay, over to you, Lifeng.
Thank you, Joey. Thank you, Rick. Hi everyone. So today we are going to do some TensorFlow Study Jam. I hope it's not gonna be too nervous for everyone because TensorFlow, right? It could be a bit intimidating for some who wants to learn machine learning, but it's not really knowing how to get started. So we are here to help you go through some of the getting started tutorial. So how we are going to do it today? I'll give a bit of the introduction as in a different way, more like use case scenario or on the how we are doing programming, and then the traditional programming and how we are going to solve a problem in machine learning way. Then we have follow up with a few practice exercises, some hands-on coding in collabs. So don't worry if you have no any environment set up, things like that. I'll show you the link how to get started later. Then after that, we will follow with some exercises and some question, some quiz to make it more fun. Then we'll do some wrap-ups and some references to for you to go over if you want to still continue to do more learning exercises. So right, let us begin with the short introduction. Everyone is talking about machine learning. You may already heard, or you are still wondering what exactly is machine learning. I'll directly give an real world example. If consider in this scenario, how are we going to identify activity recognition for fitness tracking. How do we want to identify if someone is in a walking stage, or if someone is running or doing some bicycle cycling or doing some golfing, etc. How are we going to solve this in our programming thing, right? Maybe I will just pause a little bit and let you give a little thought on this. Is it easy? Right, don't worry, we will go through all together. So most likely, maybe we can think of to do, if we want to know, check if someone is walking, we do check on the speed. Consider or imagine you are playing some games or Pokemon game. You'll be walking or running, that it will be notified. Right? You can't really do certain actions when you are in a running mode or driving mode. So they could be checking on the speed, where the position or movement of a person is. Then the next one, when to know someone is running, then it should be easier. If some speed level or some is let's say less than 4 is walking, then running is more than that, as an example. But then the next question will be, how about cycling then? Right, cycling maybe and most likely will be faster than walking and running, right? That's very easy. Then okay, we just add on some rules. If the speed level is at 4, then someone is walking, but you consider an intermediate speed, put it as the 12 level, then it could be a running mode. Yeah, anything more than that, then we are putting biking or cycling. So this is how we develop the case one by one, right? But then there will be cases, right? Right. So what about driving, etc., things like that? But then the rules goes on. It can be getting more and more complicated. And in some scenarios, what about the golfing then? So how are we going to develop some rules to identify how should we solve a problem in this case? Some thoughts? Or it could be easy for you still, or no? So in this way, right, we can put it in a more in a summarized way, that in the traditional programming, we are understanding the problem statement, then we try to derive some rules to solve the problem. And after that, we will try to do the coding, and then let the programming make the decision or give the answers whenever the scenario arrive, or the input gets in. Okay, right. That's is how we are doing some problem solving in traditional programming. And so for the complicated cases, right, can we do something else rather than just keep on adding more rules and more rules and more complicating things, right? So we are thinking in what about machine learning? So how is there a way that we can somehow easily, the computer or the machine is smart enough that it can identify someone is walking, running, biking, golfing, sort of, or some other activities magically, or I mean doing some prediction at the back end, right? So this is how we move on from traditional programming and to the machine learning programming. The difference is during the a machine learning way of programming, right? We are putting slightly differently. The rules is being developed somehow by the machine. It's trying to learn in some ways to recognize some patterns, and then from the inputs data, and then give a prediction answer. Is that correct? No, that is the traditional programming. So in the machine learning, we are already knowing the answer. So this, we are already knowing this person is already running, and the other person is on working mode. So we are telling the machine, the computer, okay, no, look, this person is running, and the other one is working. You do the development of the algorithm, and when there's new data comes in, can directly identify what the third person is doing without any rules, and the rules is being developed in the machine learning way. So further on that, considering the machine learning output as a model, so we have some input data in, and during the runtime, it can directly giving the prediction output for the certain answer for a problem.
Right, Lai Feng.
Right.
Maybe we can look at our Slack, and maybe we can interact with the audience for a little bit.
Yeah, sure.
So if you are having questions, you can always join our Slack and then ask Miss Lai Feng. Because there's too many platforms, we can't answer on all three at the same time. Right. So if you have any questions, you can always join our Slack. Link should be in the comments. Okay. Yep. Okay, maybe Lai Feng, I will let you continue.
Right, sure.
Okay.
So that is a simple introduction on how what is the difference between the traditional programming and also the machine learning. So maybe it's a bit still vague, right? And maybe let's try some simple example for doing some very first exercises. Then we can see more in the action. Right. So again, consider the sets of number. Right? Can we do some little exercise here? That how are we going to solve this problem? Given there is a list of the x value and y value, it's a kind of like a mathematics quiz. Let's take it that way. Maybe you can share it in the Slack. Then we know if you have the answer nicely. What we are looking here, right, is how are we going to know if let's say I give the next value, what would be the y value when the x equal to 5? So how are we going to solve this? So we will try to understand, right, the x equal to -1, and then y is equal to -2, and then when x equal to 0, y equal to 1. So maybe we can think of that could be maybe y equal to x plus 1 for this case, but you know it's wrong, right? Directly because when x equal to 1, y is equal to 4. So that is not really the case. Then maybe could that be, no, I'll let you do the max. Let's do it this way. If you think you got the answer, what could be the right, I'm seeing some answer. Y equals mx plus c, and then right, yeah, someone is getting it correct. That's Ryan, slightly, and then ending KH Lau and all. So that's good. If you haven't joined our Slack, maybe you would like to join us now, so that you know some others people trying to guess the answer. Right. Right. Yeah, maybe I'll just give a little bit more time. Someone is typing, but I'll give it maybe like just 10 seconds. I'll review the answer. Right. I'm not sure if you have guessed correctly, but congrats to those who have done it. In this case, most likely y is equal to 3x plus 1. If you can, I'll just give some time for others to look into this way, right? See if it's really the correct way. Try to ingest it into one by one and see what would be the answer if having this equation. What would be the answer if x is equal to 5? Then we will know whenever the input is trying to ask the question, right? What about x equal to 10? What about x equal to 120? Then we can use the same rules and then get the answer for the y. So this is how we are doing things. But then now the question is, can we solve this in a machine learning way, and how are we going to solve it? Right. Sorry. So when we're knowing the equation, right, then the developer will trying to program it in the certain language, right? Example, very simple one. Here it's most likely how it's being programmed to solve this little puzzle. Then we'll like to check on how are we going to do it in a more machine learning way to solve this little issue. I'll share the link. We'll do it over the collapse, right? I'll share this link so that you can get to the over there, and we'll start it. Right, let's try create a new notebook. You may need to log in using your Google account though. Before we really get started into the little exercise, right, I'll get give you a very quick walkthrough on this collapse. Maybe if you have not familiar or tried this before. Is everyone sort of like log in or get into the new collapse already? So don't worry if you haven't know really how to do it, or maybe you don't really know. Well, by the way, we are using Python programming language, this wrong. So if you are not familiar anything about this, we'll slowly get through into the tutorial. So I think I'll start to give a quick walkthrough on this collapse. So there are a few features here, very simple. One, you can see this, you can actually do some typing, right? But when there's a little icon here, that means this is actually where you can type in your codes. But so when there is let's say I'm giving some hints here. Let's say I want to import a library. So I don't think I want to say it right now. So this is where you're gonna code right now, right? I think I'll finish up the true first. Then if there's a case you want to do some texting, you can just add in this text icon. But when you want to do some code, right, you can just add in this using this little button there. So right, so and there is how we are going to do things right here. We will do everything in here. And when after you do some codes, if you want to test it out, you can just run this shell, as simple as that. So right, just give me a little moment. I'll put things up for you. Because I'm most likely for this case, I will do, let me think. I will give you a little bit on the what we are going to do directly, but you can directly do some coding hands-on on your side. So remember earlier the same scenario, I'm using the same case, the little max puzzle. Here, and how are we going to do it in the machine learning way, right? So as you can and think of in programming, then we must need to start up. We need to import some classes or some libraries, right? In this case, first we will do the imports for the libraries. What are the libraries that we need? Of course, it's TensorFlow, right? Because then is the TensorFlow Study Gem. What else? The other little library package is NumPy. This is to a very useful Python libraries to represent our data as least easily and quickly. So to do it, you can just do the import TensorFlow, and then the same things for the NumPy, and we also need the Keras framework so that we can define a neural network to do the sequential layers and the prediction layer data. Not sure if everyone okay on that. You know how to start, right? Maybe I'll just do a little example. So in your collapse, so you can just type in the code shell. You can just type in what is being displayed here. But I think I'm not gonna type one by one in the screen. Otherwise, you'll be just seeing me typing, right? So that is very easy, right, to start up. Before we go into details how we're going to solve this. So the very first step, import libraries. And what are the libraries? Definitely the TensorFlow, and then some other little library. There is, for this case, is NumPy. Then, yeah, sorry, but then please take note that we are doing it in a slightly different way, that it don't be afraid or feeling puzzled when there are things that you don't really understand it. This is how we are doing this little study gem in a slightly different way. We'll go through some codings without really fully understand what are the things behind it, but then slowly we will go into the concept of each one and the terms in the neural network or the machine learning way. So then we want to define the neural network. How we are going to do that is we are going to do the import from the Keras sequential, and we can just start with one single unit layer or the neuron, and also the input shape as just one, because this is quite a direct or simple problem to solve it. After you have typed this, right, then the next one would be, just ignore the little explanation here. The next one would be the model compound optimizer, and then the loss. You may be wondering what are all this, right? When we do the compound, normally we will put in the two specific functions. One is called loss and one is called the optimizer. And what are these two means is the loss function is trying to guess what are the answer and measure how is it being predicted or being guessed correctly or badly. Then on the other hand, we use the optimizer functions to do another guess and to see how the loss function went and how we are going to minimize the loss. So I'm gonna stop here a little bit, and while waiting for you to do the code, right, can just run the first shell. It's either you click on the little button here. There is a few ways, or when you click on this, I can also do it in shift enter mode. Then you can directly run the shell. So as you notice here, as I go in, right, after being compiled, there is a little numbering here. That means it's already done compilations. So the third one. And if you are thinking what is SGD and what is the mean square error and things like that, these are all the mathematics algorithms, but we are not going into very deep on this part yet. But we'll go through the whole exercises and come back to it slowly one by one. Because there are quite different optimizers and loss functions that we can use in different scenarios, and you will slowly learn different optimizer and loss function later. And for the we will try to hide as much of technical explanation as possible, so that we can quickly get the fun of the machine learning first, because maybe everyone is thinking how much math is very difficult because a lot of things is under, but we can do it into smaller steps. We understand some other basic thing of flow first, then we get into some of the concept one by one. So after that, you can just do the putting the input into the data as an array. This NP is the numpy, right? And you put in all the list of array into the input, and well, believe it or not, you are actually ready to do the training. It's just very simple, few lines of codes. You are actually ready. So to do the training, we are actually calling this model to do the fitting, and the input is the data X and Y, and we will do the let's see 500 epoch. So let's try to run this. You will see, yeah, this is how it's being trained at the backend. The epoch just take it as how many times you are going to run the guessing and optimizing the loss to do the prediction. So when everything is done, you can see the epoch is already 500, and there is time for each epoch being run, and there's this loss output. Again, what is the loss, right? It is trying to calculate how well the machine can guess after doing some learning and derive the rule by itself. Do you think this is a good one? Would it be a bigger loss better, or the smaller loss is better? You can guess that. Of course, it will be, as the loss output is smaller, then it's actually the better it is. So you can see that when you can actually trying to do some adjustment when it's trying to getting better and better, and to do the best of the guessing. Right, so this is how you do the training. and it's done. So let's see what about after we have done the training, right? We want to do the prediction or the guessing or to solve a new problem. When the x is equal to 10, what will be the y answer? So you can easily do that by typing the to print out the output of the model predict, and this is the new input value that you want to do it. If what would be the guess? And what is this is how the machine learning is predicting, or the model is predicting the answer, right? But why is it the real answer for it? We know that is what y is equal to 3x plus 1, so it is 31, right? But then why the model is giving 30.99? Is it good enough, or is it making a correct guess? How can we think of this? So as you can see, right, it's actually trying to do the prediction. It's trying to guess as close answer as possible to the real answer. So if you remember, there is a kind of like sort of answer. It's trying to guess, but when we round it out, we can also say that it is correct because it's 31. We can consider it as 31 as well. So this is how we are going to solve this in the machine learning way. Right, I hope everyone is following. Let me check on the slide if there's any. Okay, I think I should speak louder. Right. Yep. Cool. I hope everyone's get there because I don't really see issues being posted up in Slack. So very simple, right? I hope you get a gesture of how the machine learning, or how we can do some problem solving using the machine learning way. Right. I'll just leave this for a while, and maybe we can have a little break. Sorry. Before we proceed with the next session. So this is how we solve these little equations in the machine learning way. Right. So we are gonna do a quick, give a little break here. You can digest a little bit, and or maybe if you want to try some other, going through some other predictions, that you can actually try to give a different input arrays here and train the model again and do some prediction again to get some more exercise on hands-on. Right, back to you, Eric. Maybe we can have a break.
Okay, thank you, Sean. Didn't realize it was muted. Right, so okay, so this is Code Labs 1. So we just came back from a break. Let's wait for the speaker to get ready, and then I'll put her back on. And if you have any questions, keep asking, and then she'll try to answer as to when she got time. Okay, yep.
We are going to directly go to the continue on the coding session for the second part. If you think that the first exercise is too easy, let's move on for more fun part. Maybe we can try on a little exercise on the computer vision. How about we try to do some training on the images? Right, I'm just gonna skip this first and we directly go to the link. So in the next one, to make it easier, right? I'll just share the Python notebook together so that you can just walk through together. So in this little exercise, we are going to do the trying to solve a problem on the images. How are we going to train a model to recognize 10 clothing type? So we are using the fashion database, feminist database, where it already contains lots of images, and there are 10 types of classes of different 10 types of clothing, such as the t-shirt, trouser, some dress, sneakers, bag, and things like that. This is the preview of the images. So thinking about this exercise, right? If we want to do it in a programming way, it's gonna be a bit challenging, right? But in machine learning way, it can be done in a quite nice manner. So first step, of course, import libraries again, right? So as it goes by, we will add in more libraries, and for this case, we are adding in a bit more on the matplotlib to show some chart visualization. You can type it side by side on your new notebook. While I can just do the walk through on the codes. So if you want to check on the TensorFlow version, you can just, very easy, just print the version out. But this is something new, additional information, right? So now we have the libraries, but we need the data set, right? Don't worry, it's very simple. It's already available from the Keras package. So we just try to import the data set into this variable called MNIST, and we are trying to load the data into training images and testing images. And of course, when the training images, we have the corresponding labels, right? And also the test, so is the testing labels for the test images. But you may wonder what is really in. So here I can show you a little snapshot or preview on the images, some random images, so that you can have a better view on the data what we have importing. So here, just take it very easy. We are using the matplotlib, right? And I'm trying to importing 25 images here, 5 times 5. So this is 5 times 5. I'm trying to loop it, and I'm trying to show the training images with the training labels. Again, don't worry much on the details yet, but we can just have a very quick run through how we can do machine learning. It's just a getting started point of your, right, to have a feeling how it can be done, and slowly we learn what are the concept behind. Yeah. This one is actually the same. So you can also explore in a different manners. You can just put it in. So these are our data after loading in, and we are trying to do the training on all this. You can already see that how the images looks like for in the machine. You, as a human, you can try, but a bit also sometimes a bit too difficult to do the guessing in this, right? But this is how the machine is looking into the and if I can still add in more things. And this is actually a class of 9, and 9 is, I need to check back here. Is input. I would have guessed it could be a dress, but yeah, okay. Sorry. I'm not sure if you realize my mistake. Because just now I'm showing the images is and the label on a different. So the label is the it is a dress, right? Yeah. So I've guessed it correct. But anyway, this one is just a different way of showing things. The thing is you can display or visualize it in the different more information way. So here is all the pixel values from 0 to 255. I can actually show the this is how it is in the at the back of the scene. So it's actually the whole long array list of numbers, digits, right? And guess what? Is all these numbers are. It's actually the pixel value of every single pixel. So every single pixel's value here. So it's being set into an array list. Right. I'm gonna stop a while here or pause a while here so that you can try out different things. You can play around with the codes to get some other experience on the data exploring. So next we will be doing some data pre-processing. So we know that the is a long list of the pixel values, right? And it's like in between 0 to 255. So we are doing a little bit processing, pre-process on the data, where the process is called normalizing, so that we can simplify a lot of things to make the values all in between 0 and 1. So this process is called normalizing. Very easy way. And after that, I think this is the same, the one that I actually shown earlier. So these are after normalizing the images. And so after normalizing, then we can already start defining the neural network. And here we are going to try different things, because the first one is quite direct, simple one. And now we are trying to do a different format. So if you can recall, the model sequential is still the same, but the inputs we are doing different things. the to do the flattening, so that we are actually putting things, the input or the data into the one-dimensional set. So it is, and then the concept of dense is to add on the layer of neurons. And then there's also something new on the activation functions. We are not going into details on the mathematical or this part of this. Just know that we are using an activation functions called value, and then we are also adding into the dense another layer, and the activation is called the softmax. So the differences on the ReLU and softmax, a simple introduction. So when the softmax, right, you can actually taking the maximum out of the little list. So right, so in the example here, we can just putting things into to make things simplify. And because it's always looking into the biggest value, so that's why it's calling the max and not the min. Okay. Right, and for the value activation, it is trying to just again simplify things. Just take it this way: to when the x value equals bigger than 0, you just return xx. Otherwise, it's kind of 0. So again, because it's in the neural network, it is too complicated, right? And we are trying to simplify things here and there for the neural network training. But don't worry too much on all these concept and things like that. With later we can go through some of it if we have time, or I will share some of the links for you to go through into more details later on, so that you can. But the focus or the objective here is we can have a hands-on of quickly to see how things being done. So after setting the neural network, very easy. We are doing the training on the neural network. Here is something very familiar. If you can recall, we are calling the model.compound, and we have an optimizer and a loss. And for this time, the optimizer, we are just calling the Adam, and the loss function, we are using the cross entropy categorical cross entropy, because we want to try to do some guess. Right. Then we're trying to put everything not everything. I mean all the training images and the training labels into the model. We can start with a very simple 5 epoch first and do the trainings. So you can notice that here the training somehow, I mean the steps is kind of a bit of slower compared to the previous neural network training for the simple equation in the first lab. There are the few reasons behind this. One is because the array is much larger, right, in this sense, and the data input is much bigger data set. And also we are doing more complicated neural network design in this sense, because we are giving more than one layer of neurons and things like that. Right. So the training has completed for 5 epochs, 5 rounds of training, and the loss is what we can get is towards, maybe it's slightly different from I just said, but it's more or less the same. The loss value is 0.264, and the accuracy is 0.9028. In a different way, if you times the percentage, right, the accuracy is around 90%. So, okay. Not bad, right? It's just very simple training, and we can get a 90% accuracy. But is it really the as accurate as it is? So we are going to do a evaluation on the model. So this round, we are going to do the evaluation not on the same model, but on the testing images. And this is why the reason we split the data into training and testing while we load the data at the beginning. Don't worry about the others. It will quite change different ways. This is the value I get sometimes. So, and why we are testing it in the test images and not the training images? It is because we are letting the machine to recognize some of the images, right? But we want to know how well it performs, so we give something that the machine is not trained on, and we are trying to see if the model is doing okay or operating well in that. So here you can see that if we compare, right, if we use the testing images, the loss value is 0.34 and the accuracy is 0.87. It's slightly different from what we are getting from the training data. It should be right, because it's something different, right? And we are trying to see how the model is performed when we are trying to test it in a different other data set. But it's still quite okay. Let's take it, because it is considered 87% from the training result, 90%. Okay, so it differs a bit, but maybe we can accept it. But we'll try to see things how it goes. So here are some some exercises and also some quiz for you to try on to see and try to guess what are the things behind it. But we will go through together later. But I will leave it for you to play around with it, or do some thinking what is happening and why the result is that. you may post some answers or your guess in the Slack. I will go through it. I see if please just focus on the exercise 1 and until this question 1.1 or quiz 1.1 session. I have not. I'm going through the list in the study gem chat room list, but please feel free to shout your guess in the Slack. I'll slowly go through and I'll reply some of the question later. So the question here is, what is the list, this little list about? Is it a 10 random values, some percentage, the 10 classifications in the computer predict, or the probability of each item of 10 classes? So what would that guess? I hope it's not too much of numbers and mathematics for you to maybe you feel too much already, although looking at all these numbers and don't know what it's all about. But let's go through a little bit thinking process, like I said earlier. So we are, when we print all the what is inside these classifications, right? We just output the taking the first element. So it's just print out a bunch of values, and there are, if we calculate it, there are actually 10 value. And when we try to print out the test label of the first, 0 is the first element, right? We will get the 9. And what does this mean? So why it gives 9 out of this value? Hint, we are trying to do the evaluation and we do the accuracy or the loss right. So is this value related to the accuracy or loss value for the output from the model? And why when we print out the prediction, it will try to predict the class is number 9. That is because among all these values here, the highest value is the last one. And so it is predicting the output as the 9 class. So the correct answer for this is the probability of the element for these 10 classes. So meaning that when we input an element in to do the prediction, right, it is doing the outputting the value for each and single class that is trying to predict. Okay, the accuracy or the percentage, or no, okay, can I say percentage? The value for how likely the element, the first one is let's say 4.9, and so on and so forth. Because why 10 here is because we have these 10 classes, I mean. And this is actually the first element that we want to try to predict. Right, so the correct answer again is just a list of the probability, how likely for this item is a boot or is a it's a t-shirt or a trouser or pullover or the ankle boot and things like that. So the most likelihood for the prediction is number 9. So that is actually it's trying to it thinks most likely the image is an boot. Then further than that, how do you know that this list tell you the item is an angle? I think I give you the answer already. So next, I think we can try one more on the exercise here. Is second one. If we try to change the dense layer to different layers, how things is? You can just try to run this. And see how it is performing. Take a guess while you are trying to, while you're waiting for the training. Could it be when we increase to more neurons, what is the impact? The training is taking longer time, it's gonna be more accurate, or the training takes longer but not much on the accuracy, or could it be taking the same time but it's more accurate? Right, the training has completed and it's already giving the output. So the answer you can already guess. The training is actually taking longer time, but it is actually more accurate. Why? Because the earlier example, the prediction is still the same. The class is trying to, the answer is returning 9, right? But for the values here, the first one is 7.55 and then the last one is 9.76 compared to the earlier one. The first one is 4.9, the last one is 9.66. So the accuracy, the highest accuracy again is still the last one, but the accuracy rate is higher. For others, you can continue to try on some other exercise, 3, 4, 5, 6. I think there are quite some other exercises you can go through and have some thoughts on the exercise. So we can share the questions in the Slack. Let's see. Yeah, sorry, I want to turn the number 3. Exercise number 3. So just now we have the flattening the layers, right? If we remove it, what will happen? No, yeah. To remove it, this is the original one. You can just replace with the comment out this part and run this part to get the error. That means we remove this line. But now it's training, right? But if let's say if now I am doing the this out and we'll run it again. So you can see there's already a value saying that now what is this value means? This error message means the shape mismatch. The shape of label should be equals to the length and dimensions. this back to a bit on the mathematical side. The name is we are putting everything into a one-dimensional array. Without it means all the layers you will get a mismatch. And that's the reason why we do the flattening. Can continue for the other exercise. We are quite running out of time. Okay, so while you are trying some other things, maybe we can have a short break here and we will continue on exercise 3 later to look into some other things. Back to you, Eric.
Okay, thanks, Laifeng. So we're gonna be back in about 5 minutes for a break. Thanks a lot, Laifeng. So we're gonna go with collab number 3 after the break. So, yep. See you in 5 minutes. Okay, thanks for staying with us. We are going to continue with, let's see. Okay, code lab number 3. And Lifong, you ready, right? Okay, I'll pass it to you now.
You kind of enjoy the session and not getting to the back off from the exercise. Now, looking back at what we have done so far, the first exercise, we are trying to solve a little math problem using the machine learning way. Then after that is on the second exercise, collapse exercise, we are trying to do a neural network machine learning training using images. That is a quick way, and I hope that is not too much to digest. But if you think that you are kind of lost here and there, don't worry and don't feel afraid of this machine learning is too hard. It will need some time to digest and pick up things here and there, but eventually you will get to develop the skills. So next we will try to look into the convolutions. It's just a quick introduction on the convolutions, and I have, okay, please follow the URL to get into the collapse link. So a bit more theory or explanations, but we will go through. So earlier on, we have done the computer visions problem solving using the convolutions. But what are convolutions? So here is a let me directly go to here. I think the if we think back what we have done in the second exercise, we are actually trying to train the images, small little images, 28 times 28, I think. But now, if given in the real life scenario, we have this nice boot image, we want to do the prediction. in this context, how do you think that it can classify this image? So the convolutions idea behind is quite rather simple actually, but when it comes to big array list, then things get complicated. But what is behind in basic, right? Back to the basic, for each images it is actually some pixel values 0 to 55 at the end. And let's look at this first image. If we take an area on this and we look into the 3 times 3 matrix, right? So these are consider the first point is 0, and then the second pixel is value is 64, and so on and so forth. Then what is trying to do next is we to this the middle value is 192, right? So the current pixel value is 192, and considering the neighborhood values of it, surrounding of the 192 values, we are trying to do a filter again. Just take the first without going very technical into the mathematical calculations and all. But in here, you can actually know that can do some small calculations for this part. You know what it's trying to do, right? It's actually trying to times the first value 0 times or -1 times 0, or the other way around, to each matching value in the matrix. So this is the calculations. So the new pixel value is the total of summation of the multiplications of the neighboring pixel value. This is what 3 times 3 convolutions means. When we talk about convolution, it is actually putting in a filter and to get a new pixel value. I will pause here so that you can digest a little bit on here. Right, so having this little concept in mind, right, we're trying to do a little bit of coding here. In a using a different examples, not using the same fashion in data set in the earlier lab. So here I think it's pretty direct. You can we have some other libraries here to look into. So this is input image that we are trying to work on. I'll just quickly run through everything first so that we will come back. And here later you can just play around with different filter to get a feeling of different results. So here is how we are deriving the convolutions. And now we are displaying the result of it and putting the original image, and this is the filter, and we get the output. So using this filter, what we can get is the output image. It is giving a very strong set of vertical lines here. You can see all the vertical lines and filtering out some other informations. The other, if you change to the other filter and run things again, right, you can get a different result. Just run this, and then we run through the conversion again. So this is the second image. It gives a stronger result for the horizontal lines. So this is the what it means by convolutions at the back end. I'll give some time to experiment a little bit on yourself. Then we will continue after this into the next concept. Little bit on this is you know for just to get the result, we can do it this way. If we are ready, maybe we can go for the next concept of pooling. So what is pooling about? So imagine this one is the front is the image, right? And the backend is again is the pixel values between 0 to 255. And taking into the smaller matrix, let's say this 2 times 2, and we put it focus on this region here. So it's 0, 64, 48, 192, and the second one is the next one, 128, 128, 144, 144, and the third region and the fourth region. So for every single smaller region, right, we are getting the max value of the single region. So for this, very easy is 192, and then this one is okay. You can just take the max of either 144, then the 255 and 166. Then from this 4 times 4 matrix and make 2 times. So here what does it means really to some options. So let's take a look on this part. This part of the code is basically trying to do the same things for the above formula. So this. What do you think about this image? Compared to the original one. The difference here, right, is actually being reduced already. This image size is 500 times 500, but this one is 250 and 250. But look, this is the small details. But in the picture itself, right, we can't really see much of the differences. So the size is being reduced, but we cannot maintain the features or the quality of the image. If you are curious, you can play around again to look into a different pooling and can check on the results. Right, I give a bit more time for you to digest, and then we can try to apply this concept into the second exercise so that we can have a better result. So we will continue the left 4 section after a quick break, maybe 1-2 minutes, or so that you can quickly wrap up the exercise 3 and just get the clearer picture or some basic understanding on the convolutions and pooling. Okay, Eric, maybe we can go for a break. Welcome back. So now we will continue on the next little exercise, a quick one. Picking up the concept in like three URL that you can go to pull up the collapse. Already in. So we are going to use the exercise 2, but everything the code is actually being put in here. It's actually the same code. So this is it is kind of direct when you just do the coding. I mean, after you know the concept behind what is really running behind the code. So I'll just do a quick one, but you can just continue. So this is the original way where we are. The sim patient name is dataset, and we are doing the this is directly from the second lab actually. Then we got the accuracy rate right this time. Then what we want to do now is we are trying to do the adding into the ReLU softmax. I'll try to go through a bit on the explanation. This is where we mentioned the 2D convolutions, and we use the activation function called ReLU. And then we got doing the max pooling to 2 times 2 matrix. So these are the different layers of the neural network. In the earlier, the accuracy is starting from 0.82 and end with 0.87. But for after we putting into this, the can directly see the accuracy is immediately increase and slowly it's improving as well. But at the same time, we also notice that the training is taking longer time, right? Because you are adding more layers in and more calculation is needed. Can go through a bit more details later. you can, which is already done. So you can already see it's already improved, but you can actually also try to experiment with putting in more layers or more epochs, so that you can see it can still be improved. But when there's more epochs running, you have to be careful that it can be overfit, as in it is trying to mimic too much, and when there is some other new data coming in, the accuracy will be actually dropping. It's not that accurate, although the accuracy is very high. So we have to, there is a different problem, we call it the overfitting. So that is how the concept comes in. But again, please feel free to play around with the epochs value to get a feeling on that. But I'll leave it for you to run in on your side. You can go into the details, more explanations. I think this is what we mentioned earlier, but you can also do the pooling. This is very similar. You can just go through, but it's quite interesting to see the different in between. What is actually happening inside. And you can again experiment using different values to see what would be the difference in the output, to get the better understanding on the impact on the output and etc. So let me just run this while you can just, while we wait for the epochs running. This is 10 times of the epochs, and we are actually changing a few things here. this may take some time to digest and to it's important for you to go through the exercise yourself first to get some clearer understanding. So during the training session, it can be very time consuming, especially when you are working with a large data set, and also if it's a complicated neural network, but we are doing not too complicated actually. This is Right, for this session, the training has been done. It's giving a very good accuracy, 0.98, with some little tweaking. So we are actually designing the frame neural. This is, you can see that you experience problem. You
Okay. It seems that Lightphone's internet has been cut off. Sorry, let me just try and get her back. Yeah. While we wait for her to reconnect, if you're still with us, maybe you can fill out the feedback form and see if we help us improve our events in the future. And also thanks for staying with us until now. Still with us. Send the links. Okay. All right, let me just try and get her back. Okay, she managed to reconnect again. Sorry for the technical issues. Internet is bad. Right. Just hi, Lai Fong. Everything good? Hello. Okay, I think I can hear you now. I can hear your background.
Okay.
Okay,
Right.
great.
Maybe I'll just repeat again. I hope everyone is still okay with the session and not getting too much overloaded in the 4 little exercises. I think if you are kind of following, you are doing very good job. And if you are still kind of lost here and there, don't worry much. Maybe you just need some more time to go through the exercise at your own pace. And if there is more question from you, you can just always discuss in the Slack channel later. Right. I think we are good on the exercise 4 already. Maybe can we already switch to the next session?
Yeah, sure. Okay. So we can wrap up now. Right.
Right.
Okay. Thank you so much, Lai Fong. Thank you so much for your sharing. So I think that should be it, right, Lai Fong?
Yes, for today, and I hope you have learned something from the session. So for a quick wrap up on the 4 exercises, we are actually doing things in a slightly different way this time. Directly go into the little scenario on the mathematics equations solving, and then into a more complicated exercise on the image or computer vision issue. And along the way, we pick up a few concepts and terms, machine learning terms, terminologies. And right, I think that's about it from my side.
Okay. All right. Thank you, Lai Fong. Okay, let me just show this back. So again, if you're still with us, please do fill out the feedback form. And if you're watching this again, because this stream will be recorded, right? So if you're watching this in the future and you finish this, do fill this in as well. We won't be closing this. Yep, I think that should be all. And Lai Fong will be still on Slack if you still have some questions, and she'll be trying to answer them. But otherwise, I think our time is about to be up. We only have 7 minutes left, which is great timing. Thank you so much, Lai Fong.
Thank you, Eric. Thank you, everyone. If you need more understanding on the concepts and things like that, I think a good reference or link you can go in is the machine learning crash course by Google. It's very useful for you to even go deeper or better understanding on the concept of the neural networks and machine learning. But we are doing it in directly from the code first. Yeah.
Okay, cool. Right, maybe we'll share the link and then in Slack. And if anyone's still on YouTube, maybe you can share it there as well. So yeah, thank you so much. Right, yep. So this is from GDGKL, as I saw a question already. So we are GDG Kuala Lumpur. So yep, to whoever asked that question. And also, we'd like to give a shout out to our Google developers based Singapore for helping us prepare for this event and also giving us some support, especially allowing us to stream on their YouTube channel, which is great reach to more people. Right, I think that should be it. Yeah, thanks for coming. I think we'll end the stream now. Thanks, Lai Fong. Bye.
Thank you. Have fun.
Yeah,
Try
have fun.
Bye-bye. See you next time.